Our seventh graders, we are on Unit 20, the last unit of the year. And in Unit 20, we're talking about percent applications and finding simple and compound interest. So in Unit 20, Part 1, we're talking about percent applications specifically. The first thing we're talking about is how to find a retail price. A retail price is what you pay at the store. So if you go to, I don't know where you crazy kids shop these days, if you go to, I don't know, the Gap or something, the price you pay is the retail price. Now, the retail price is a combination of the wholesale price and a markup. So the wholesale price is how much the Gap buys from manufacturers, so it's cheaper than what you pay in the store, and then they mark that up to the retail price. So the first thing we're going to look at is how to find a markup price. With a markup, your price is always going to go up. So it says find the new price. Our wholesale price is $18, and we're going to mark it up 105%. Now this is very similar, or basically exactly the same as what we did in the last unit, when we were increasing the amount by a certain percent. So our new price, which I'm going to call X, is going to equal our wholesale price times 100% plus our markup, right? Or sorry, our markup percent of 105%. So again, what we mean by this 100% is our original 18. 105% is what we're adding to that, or the actual markup itself. So I'll get 18 times 205%, and then we know from last unit to actually multiply those, I need to turn 205 into a decimal, so that's 2.05. So my retail price would be $36.90. So if we're marking it up 105%, that means we're more than double. Marking it up 100% would be doubling it. We have 5% on top of that. So number 2 I'm going to leave for you because it's exactly the same as number 1. Just go ahead and try that on your own. The next thing we're going to talk about is finding a sale price. Now a discount is a decrease from the original sale price. So when I say sale price, I don't mean that it's on sale. Sale price means how much you sell it for. So a discount is then a reduction in the price from the original. So like if you go to the Gap and they have a 25% off sale, the sale price is what you'll pay after that discount. So to do this, it's going to be a lot like what we did in the last unit with decreasing numbers 5%. So my discount price, which I'm going to say is X, is going to be my original price times 100%. And since it's a discount, I'm going to subtract the 25%. So when it was a markup I added, with a discount I'm going to subtract. Again, this 100% is my original $22. 25% is how much I'm subtracting off of that. So I'll have 22 times 75%. And then to multiply that, I need to turn 75% into decimal, which is 0.75. So 22 times 0.75 is going to give me $16.50. So if you think about it, I'm reducing my price by 25%, or I'm saying I'm only paying 75% of that price, so it should be a little bit lower. Number 2, I'm going to leave for you because, again, it's the exact same thing as number 1. I'm moving on to the back side of your notes. We're going to look at finding the cost of the meal. So we're going to include tax and we're going to include tip. Now, in real life, if you went to a restaurant and tipped, it would depend on how you do it. For instance, I tip after I get the total bill, including the tax. Some people tip based on the bill before the tax. What we're going to do right now is we're going to do everything based off of the original food bill. So here's what I mean by that. For both tax and tip, we're going to be adding amounts, so it's just like an increased percent problem. So my total bill is what I'm looking for. So my total bill is going to include the $9 plus 6% of that $9. So that's 6% times 9. That's the sales tax. Plus 20% of that $9, which is the tip. So I'm taking a percentage of my bill for tax and a percentage of my bill for tip. So that's going to be 9 plus, and then I need to turn 6% into 0.06, and I need to turn 20% into 0.2. And now I can multiply and add it all together. So I'll have my original $9. 6% is going to be 0.54, or since we're talking about money, 54 cents. 20% is going to be 1.8, which is $1.08. So when I add all of those together, I get $11.34. So that's my total bill with 6% tax and 20% tip. All right, number 2, I'll remove you guys again. Exact same type of problem. Now these problems at the bottom are going to be a little bit trickier because instead of finding the markup price or the discount price, we're finding the original. If you remember when I did all the previous problems, okay, I put an X over here on the left side. The reason why I did that is to show that there's something on that side of the equal sign. Because now when we come to this, it's going to make a lot more sense. So it says to find the original price. For number 1, we have a retail price and we have a markup percent. So we want to find the original price before it got marked up 75%. So now my X I can replace with my retail price. So remember on the other side, this 14 would have been an X, but now that's what I have. I have that. Now I know that's going to be equal to my original amount, which I'm going to call X, times 100% plus 75%. Sorry, times 100% plus 75%. So this X I'm looking for right here is my original amount. So now I can add together within the parentheses, I'll get 175%. And then I can turn that into a decimal, which is 1.75. Now, I like to write this 1.75x just because of my algebra side of my brain. It makes more sense. But either way, to figure out what x is, or the original price is, I'm going to divide both sides by 1.75. So when I do 14 divided by 1.75, I wind up getting $8. Now, I wanted the original price before a markup, so it makes sense that my $8 would be less than that $14. Looking over at number 2, it's the same kind of problem, except now we're given a sale price after a discount. So we want to find the original before we did the discount. So X will be replaced with the sale price this time, and now I'm looking for the original. I have 100%, which is my original amount, and this time it's going to be minus 40 because it's a discount. So 21 equals, I do 100% minus 40%, I get 60%, which if I turn that into a decimal will be 0.6x. So now to solve for my original price, I'm going to divide both sides by 0.6, and I'll get x equals $35. Now if you think about this, it makes sense. Our sale price is $21, so our original price needs to be more than that. All right, on the bottom there's some review problems that you need to do. If you have any questions on part 1, just let me know.